All right, welcome everybody. I hope you're having a great JupyterCon. Our last talk is by Amit Rathi. He's a software developer and the founder of ReviewNB, a code review tool for Jupyter notebooks. And he's going to talk about building GitHub code review experience for Jupyter notebooks. Let's give Amit a round of applause, please.
Hey, thanks for coming out. I know it's the last talk of the day, at least in this hall. So I'll try and keep it short, make it useful and interesting for you. So I'm Amit Rathi. I'm founder at ReviewNB. It's a code review tool for Jupyter notebooks. And today I'm going to talk about our experience of building this GitHub code review tool for Jupyter notebooks. First, a bit about myself. I'm just a developer at the core. Enjoy building new things, writing code. I previously worked as a software engineer at Amazon and Hypertrack. I studied at Carnegie Mellon. I started ReviewNB back in 2018. Next month, it will be 5 years. It's a small bootstrap company out of India. I will be building this code review experience as a GitHub Marketplace app for Jupyter notebooks. From last year, we're also supporting Bitbucket, so it's GitHub and Bitbucket app now for notebook code reviews. This is a bit about ReviewNB. With tens of thousands of users, hundreds of thousands of notebooks being reviewed on our platform. It's completely free for open source and education. So we see a lot of uses from academia and open source world. So let's get started. What's the agenda for today? I want to quickly go through, set up the context of what I mean by code review, so we're on the same page, and then why should Jupyter users care about it. But I want to spend bulk of my time on the challenges we faced in building such kind of experience of code reviews. So you'll appreciate it. There's many builders of the tools in this conference, so you'll like that. And also, from a user's perspective, you'll see what's important, what's not, and what goes into it. So with that, let's get started. What is notebook code reviews? To give you a definition, it's your teammates or colleagues asking questions, providing feedback on your Jupyter notebooks in the form of written asynchronous communication. That's OK for the definition. Here's how it looks like in practice. Here you can see there is a notebook cell, and we highlighted what the changes are between two versions of the notebook. And there is an ability to write comments below on each cell or per certain line. Those comments get notification, like posted to GitHub, and your teammates get notification, and they can kind of communicate with the context around a particular notebook, Jupyter notebook. So that's the notebook kind of review in a nutshell. Why should Jupyter users care about this? And that's a good question, because there's diverse usage of Jupyter, right? You use it for many different kind of things. So if you're using this for individual, if you're using Jupyter for your own data exploration or as a scratch pad, where I'm not going to look at that notebook again, then of course you don't need to do any code reviews, right? Like it's just something you're using and kind of move on with it. If you're using notebooks for teaching, then it depends. You could, some professors are using code reviews to review assignments submitted by their students. So that's a use case. But there are other use cases where you use notebooks to do one-way communication and you don't need code reviews. The documentation and data science are the kind of Jupyter use cases where you want to preserve the output of your work and either like refer to it in the future, use that, it's like an artifact that you use either in production or publish it somewhere, or you want to use it, refer back to it in the future again. So those are the use cases where code review kind of really shines, because then you can collaboratively get together as a team, have a streamlined workflow where your team can give you feedback, and you can essentially create good quality notebooks. What are the alternatives to this type of code review experience that I'm talking about, right? Like you could basically get together, schedule a call or a meeting, or even ask your colleague to come to our desk and go over the notebook together, right? Like it's possible to discuss this in person. And there's definitely advantages to some of that. Instead of writing 10 different comments, you could just discuss this with your team or with your teammate, and you get fast, immediate feedback. But some of the obvious disadvantages are it's not an async work. You need to schedule time, and there's no written record of what the decisions made in that meeting and what discussions led to those decisions. So this kind of context is not captured anywhere. But the biggest disadvantage of an informal code review process is there's no easy way to track multiple conversation threads across iterations. What I mean by that is notebook development is iterative by nature. You create some work, you send it out to your team, and you get some feedback. You go and improve that a little bit more, and so on. You get some more feedback. And this process could go on for days or sometimes weeks. And unless you're really diligent and write everything down, all of those discussions that are happening at various parts of your notebook work won't get captured unless you use a tool, right? So that's kind of where the informal method breaks a little bit with the code review as compared to a formal tool-based code review process. So let's get to the technical stuff. What makes notebook code reviews difficult? So there's many challenges to kind of building this kind of experience, but I listed 5 here. But I'm going to essentially go to the 3 of them at the top, kind of into more detail. And if we have more time, and maybe in Q&A or offline, we could talk about the other stuff. So the first and obvious kind of problem is the JSON file format. So if you ever look under the hood of a notebook file, it's a JSON document. Here you can see a markdown cell followed by a code cell. So what happens is when you make any changes to this document and run git diff, you'll see something like this. All of the changes in your document are highlighted, including some metadata like execution count. That's kind of stuff as a reviewer you don't care about, right? You're looking at, you want to review the actual source. And then there is some important stuff like an image changed. But even those and a textual, like at the bottom, you can see you can't read that image unless you're a superhuman. So it's really difficult to do this on a raw git diff format to build this, right? So you need to work with JSON files and be able to do build rich diffs. We'll look at some of the algorithms to do that, in the next challenge. But here's how GitHub raw diff, the same kind of raw diff looked like, a few months ago. We saw in the keynote that GitHub has actually now solved this problem, right? Now they render rich diffs, which is amazing. So this is why I say JSON file format used to be a problem, but not anymore. It's because now GitHub supports rich notebook diffs, something like this. GitLab also supports rich notebook diffs. To their credit, they built it even before GitHub. NBDime is an open source tool, has been around for a long time, and you can get local diffs using this tool. You can use NBDime to also merge your notebook changes to resolve conflicts. There's also obviously NBDev, which helps you with the merge conflicts, and there's of course ReviewNB to do diffs, rich diffs. So all of these kind of tools. This is also Jupyter Lab Git extension. So you want to do your diffs between 2 versions inside of your Jupyter Lab. You can use this extension, and this will help you with 3-way merges and diffs. So all of these tools are kind of now coming around and help you do notebook code reviews and merges, and basically essentially bridge the gap between Jupyter and Git world, right? There used to be, so I'm in this space for a long time, right? Like I've been building this for 5 years, and like initially, or even like up until like a couple of years ago, there used to be this debate whether the tools should change to support the rich notebook format, or whether the rich notebook format should change to support all of the tools, right? And I'm happy to report, I think the debate is kind of settled now, with all of these tools now actually coming around and supporting the rich notebook format, and which I think is a win for the Jupyter users, the end user. It's amazing because instead of doing like a textual kind of diff, you can actually do rich diffs with images and plots and all of those kind of, ultimately all of the tools are supporting this, means you get to use use it in a much natural format. So this has been huge challenge, but kind of solved. Let's look at some more like actual technical challenge. Like the first is, how do you actually generate the diff? And here's a typical what I call a change event. A cell is modified, like you make some changes to an existing cell that led to this plot being changed. Same thing can happen, a cell, in this case, a cell is deleted, right? There's 2 cells and the middle cell got deleted. In this case, this couple of cells are added. You get the point. Is basically bunch of change event options. A cell can get added, a cell is deleted, cell is inserted, cell can get split into multiple cells, cells can get merged, multiple cells get merged into single cell. So all of those changes can happen to a notebook and gets reflected in the JSON. Now, how do you take that and generate the diff? There's 2 algorithms, and I'm going to go briefly over them, which is, I think, technical, and you'll probably enjoy. Like, I enjoyed building this, so maybe we'll enjoy hearing about it. So the first is fuzzy string matching method. Essentially, go through the 2 notebooks, the 2 versions of the notebooks, cell by cell, and try to identify what is the change event that might have happened at each cell to get to the next version. And the way you calculate that is doing by string similarity, using a Levenstein distance, or the string similarity algorithms and such. And essentially, you generate all of the possibilities of what can happen at each cell on entire notebook, and in this possible, each of these numbers is essentially similarity metrics using like a Levenstein distance. And when you trace a path through this metrics, an optimum path with the least amount of changes, that's where you get the actual diff between the 2 files, and then you can use that to render in a rich notebook format. So that's one method. You can take any 2 files and use this, basically build this diff from scratch. The second method, which is what ReviewNB uses internally, is called git diff method. So when you make any changes to a file under a Git repository, you can access what is called as a Git patch. And it looks like something like this. Patch has all of the information about what had changed at a textual level. And each of the changes in the Git terminology is called hunk. So you essentially go through each hunk in the patch and see how it relates to the notebook changes. So in this case, the top couple of hunks are essentially just metadata changes. So for rich diff experience, you can ignore it. And the last couple of changes are actually image changes and source cell changes. So you can take those and kind of show them in the rich diff output. So this is how the rich diff output for this particular patch would look like, this particular change of the file. This is a really simple example, but you can imagine Git patches being thousands of lines long, and even while processing those patches, you might want to do some of the fuzzy string matching algorithm to get better diffs, and we do some of that over time to kind of do improved, better diffs. Well, that's some of the internals. We talked about the 2 methods, fuzzy string matching and git diff method. Both of them have certain advantages. With the fuzzy string, as I said, you can compare any 2 notebooks. So it's very good if you're using it with Papermill or something, where you have like a single notebook executed 100 times, 100 different versions. So those notebooks even don't need to be under a Git repository. You can, to this algorithm, you can give any 2 files and generate the diff. The benefit for a get diff method is performance. We're actually relying on a very well-tested, well-built library, Git, to actually get the basic level of the diff textual changes for you. So it's very performant, and kind of you build it on top of Git diffs. But of course, the problem with Git diff method is only works under Git. So if for ReviewNB, we don't support like any random 2 notebook diffs, right? That could be nice. Some users have asked for it. But with this method, it's not possible. And this is the last challenge I'm going to go deeply into. And this is probably the most interesting bit of code I've written for ReviewNB. And this is interesting because I didn't realize this becomes a problem until I started building like a commenting system for a code review. This wasn't like, it just kind of got to know about it later. And let me explain the problem first. So let's say there's a code cell, and a reviewer here has given a comment saying, can you please describe each of these functions? The author of this notebook looks at that comment and says, OK, this is a reasonable request. And the author gives and writes some description for each of these methods. Fair enough. In that process, the author changes this code, a single code cell, splits it into 3 different code cells. Now, as a builder of these tools, where do you show this comment? Do you attach it to one of these cells? Or do you show it under like a combination of these cells? Or do you just say it's resolved or something because the author has addressed the comment, the requested changes have been made. So that's kind of interesting. And this is a really simple example to demonstrate the problem. But imagine having 20 different versions of your files in iterative mode and having comments on multiple comments on each of those versions. And now you're rendering the final version and you want to show all of those comments. How do you move these comments around and show them at the right place, at the right code cell for the user? So that kind of became an interesting problem. I'll briefly touch upon the solution we did in ReviewNB. In this example, you can see there's 3 versions of the notebook file and has 4 comments being made, C1 to C4. We essentially go through each of the comments and look at the code cell on which that comment was made and try and map that cell, code cell or markdown cell. Let me clarify. Try and map that cell to what it looks like in the current version. So in this case, we looked at all of these comments, and C1 and C2 were made on really old versions of the file, and maybe those cells got deleted and they no longer exist. So we just show those comments as outdated, the comments made on outdated cells. And the C3 and C4, even though the cells were modified, we could kind of map them with enough confidence using our similarity algorithms that this kind of makes sense to move them and show at the right place. So C3 and C4 got mapped. The way you do the mapping is by the same similarity, the fuzzy string similarity algorithms I showed earlier. And then that happens, for this, it happens at a subset of the file, and not the entire file, because you have some information here. In this case, some of the cells are already deleted and stuff like that. But that's pretty much the solution to this. Now getting to the end, so we looked at basically what is notebook code reviews, why and when to use it, and we looked at 3 challenges that somebody's building this kind of would face. And there's more stuff, but I kind of want to keep it short and tight. But that's the content I had. I actually want to thank, I wrote it there so I don't forget, the GitHub and Bitbucket, because we make like thousands of API calls them every single day, and it's been a really fruitful partnership, being on their platform as a marketplace app, and kind of building this with their support. So it's been a wonderful journey. I also want to encourage people to kind of build this. So Arch is like a small bootstrapped company, and so the way we see the companies in this space are kind of really large and VC funded and all of this kind of different model. I think there's good space here to kind of build purpose-built tools for a Jupyter system. And I see a lot of this cool stuff. Like the talk before this was amazing, CoderPod, MIT license. But I also see there's also amazing space to build tools as small businesses as well. With that, that's it. And if you have any questions, I can take those.
Time up for questions.
Thanks for the talk. If I remember correctly, when you post a comment on the ReviewNB site, it also maps it back to GitHub, and it shows. Is that complicated, like what you were saying in comments changing across versions, trying to figure out which line in the original JSON it maps to?
Yeah, that's a great question, actually, which turns to be one of these things that we didn't talk about due to lack of time, but essentially the 3.4. So what happens is what the promise we give our users is we are just a tool on top of GitHub. All of the information, your notebooks, all stay with GitHub. You give us access to certain repository, and we show you the rich diffs. Every time you open a page, we make API calls to GitHub. Every time you write a comment, all of those comments get posted back to your GitHub PR page. We do not store those, and they get you get posted there. So all of your existing flow kind of continues, and all of that stuff happens. The problem with that is, and this is an interesting technical bit, is so GitHub only accepts comment on changed parts of the file in a PR. And what we realized as the notebook, there's a lot of interconnection between the cells. If you make changes to certain cell, that has impact somewhere down the line, and you want to be able to give comments on that as well. So I built actually a way that my users can actually write comment anywhere in the file. We still post it to GitHub, but with certain hacks around it to make it work with their limitations. But all of the comments on pull request gets posted to GitHub.
More questions?
I have a very specific maybe question. Do you put diffs on images even if you sort of, like, I didn't change the code, I simply run it again, and I mean the file will change, no? So do you put them, or do you recognize that this is actually the same?
Yeah, we do textual changes, which if you do the same execution, even if the output is the same, sometimes the metadata or image would change. So the textual representation of the file would change. So we highlight it because it might or might not be relevant. But honestly, like if I were to focus more time on it, I would want it to be semantic image diff, right? It needs to understand if there's actual changes in this file. Right now, we only do text. If the image binary string had changed, we show as highlighted. We let you kind of decide if it's important or not. But ideally, I would like semantic image diffs.
Thanks.
Thanks. We still have time.
Yeah, thanks. I was just wondering, well, would it work on GitLab?
Yeah, so a year ago, I tried to integrate this with GitLab, and I was talking to Corey about it in the hallway. Sadly, GitLab APIs have certain limitations that we cannot build this with them, so we support GitHub and Bitbucket. I have an open issue with like hundreds of upvotes saying, please build this for GitLab. And I wanted to build this, but I talked to the engineers there. They basically don't give us the full diff or patch of a Git commit or PR, so we can't build it. But the nice thing there is they have built some of their own inbuilt diff functionality for notebooks. And I know some engineers there who kind of care about this stuff, so you might not need a third-party tool like RC. Might need just use GitLab, continue using it.
Other questions?
Hey, so I work at JPL, so we're actually customers of yours, so thank you for making this little tool.
Sorry, where do you work at?
JPL.
NASA. Okay, it's cool.
I'll come talk to you. But so my question is, we've seen this morning that GitHub is starting to implement this feature. Do you have a plan to stay, like, how are you adapting to this? Do you have a plan to stay relevant, for the lack of a better word?
No, it's a great question. Honestly, it's actually a win for the community, I think. Yep. I think there's space for tools. So for example, GitHub, let's say normal Python files, right? And the diff around there. GitHub is amazing, it does a great job. But even there's tools to do on top of that, so specific tools like ReviewNB and stuff like that, who build still on top of that. So I think over time, we want to be the best tool out there for the Git dev, or like collaboration and code reviews for Jupyter notebooks. I'm sure GitHub would do like improve their diffs and do all of that stuff, and which is great. I think it actually helps small companies like us. It opens up this kind of market to people who didn't think about this. But I kind of want to keep building towards the best possible experience for code review for Jupyter notebooks, and I'm hoping the stuff that GitHub builds is good for maybe 90-95% of the people, but there's always going to be that 5-10% who wants the best possible experience and who pay for it. And we want to be there for them.
Awesome. Thank you.
All right. Thanks a lot, Amit, again. And let's give him another round of applause.
Thank you.